Hi everyone, welcome to Vedantu Math once again. So we are beginning with a very interesting midterm sprint. Yes. So this is for CBSE class 12. The first topic is your continuity. I know how scared you guys are of calculus. So let's take it one by one. Let's take the bull by its horns. So continuity से start करते हैं. Alright, so those of you who do not know about me, I'm Neha Agarwal and I'm Masters in Math and B.Ed from Delhi University, Hansraj College. I have more than 11 years of teaching math to students, CBSE, JEE and a lot more. I have taught more than 4 lakh students offline and online. So enough about me, let's get straight into the topic. Alright, before we do that, make sure you are liking, sharing and subscribing to Vedantu Maths channel. Make sure you keep showing your love through your comments. Alright? Okay, so first and foremost, थोड़ा सा फटाफट से रिवाइज कर लेते हैं what we mean by continuity of a function. What is a continuous function? What is a discontinuous function? So let's discuss all that and then we'll start rolling with the questions. Okay, now. So, first of all, continuity at a point. We say the function is said to be continuous at a point. So basically, let's look at the definition. It says the limit. Yes, you use limits of your grade 11. So when limit exists and is equal to value of the function at that point, okay, that means LHL and RHL we can take it separately. It also means continuity means without any bumps, without any jumps. That means yes, basically it's a smooth graph. So that means now if I can draw any graph without lifting my pen, even if I lift it once, this becomes discontinuous. Alright, so first of all, the thing is it has to be a smooth graph. What do I understand by this is basically from left hand side and from right hand side. So what do I mean by this? Alright, so the thing is, if I'm talking of this point A, so I start moving from my left side, I reach this point, I approach this point. I start moving from this side and I approach this point, and also the value of this function is exactly giving me this point. So automatically completes the whole smooth graph and I don't have to worry. So that is why from the left, from the right and the value of the function. So here I can write it as, if I'm talking of a point, limit x tending to a minus. अब सोचने की बात है, minus का मतलब doesn't always mean that the number has to be negative. It simply means that we are approaching from the left side of the number line. Okay, so this of the function is equal to limit x tending to a plus f of x is equal to value of the function at a, right? So all this makes sense. Are we good to go? Yes, let's do that. Alright, so moving further, that's exactly what we said. So for continuity, this is the content we require. And if I'm trying to say that fx is not continuous at a, then that means it is called to be discontinuous. थोड़ा सा explore करते हैं इस discontinuity को before we dive straight into the questions. Okay, so let's go ahead. Reasons for discontinuity. As you can see through the graph, this is very clear. First of all, I'm trying to say that the limit does not exist. Okay, अब इसके क्या चीज़ है? Now what all is related to this? fx is not defined at the point where we are trying to establish our continuity. Like if you look at this one, there is a hole, there is a gap in the graph. So it's not defined. Or a and b are giving us different values, right? Or if we say, alright, or if we say that the limit exists but is not equal to the value of the function, तो बॉस हो क्या रहा है? Basically So there are three conditions we say it fails. The first one says that LHL exists independently, RHL exists independently, but both of them are not equal to value of the function at that point. Okay, so this is one thing. Secondly, we are trying to say that LHL and RHL themselves are unequal. Okay, they are finite but unequal. Thirdly, that they do not even exist. That means they become not defined, right? So that means if you look at this last box which I have highlighted, for a function to be continuous at a point, LHL, RHL, value of the function should all be finite and equal. Otherwise it is discontinuous. अब इसी concept को थोड़ा आगे बढ़ाएंगे. So what we are learning at a point can also be dragged to a specific interval or the whole domain. मतलब बॉस, अगर एक इंटरवल हमने लिया, let's say my interval AB, and I want to check for the continuity. Okay, there is no specific point given to me, एक direct function. So that means if I take any arbitrary, any random value nahi, but any random, let's say C belonging to this AB, and if my function comes out to be continuous at this point C, which we know how to check for continuity, LHL at C, RHL at C, value of the function at C. If all that is equal, then in that case, simply the function is continuous on the whole of the interval. Same way, agar koi domain ki baat hai, again we take an arbitrary point, say that it is continuous, and thus it is continuous everywhere, right? That's what we talk about. Okay, so now let's move to our sprint. Let's start running and let's start doing some questions. All right. Okay, before we begin, there are very important, we are talking of algebra of continuous functions. Matlab addition, subtraction of two continuous functions makes a continuous function. Ab ye, this could be, now I wish to add this. Now I can say this happens at a point, at an interval, or on the domain. So matlab, if my function is continuous, suppose my function fx and gx, they are both continuous at a point A, then fx plus gx or fx minus gx will also be continuous at A. If both of them are continuous in a specific interval, then their subtraction or their addition is also continuous in that interval, and likewise in the domain. Okay, same way, product of two continuous functions is also continuous. Again, whether we are talking on the point, we are talking on the interval, we are talking on the entire domain, right? It is also continuous. So even the quotient we can say, but then we have to be sure that the denominator doesn't become equal to 0. Okay, all right, addition or subtraction of discontinuous function with the continuous function still stays discontinuous. ठीक है, ये तो आपका rational plus irrational वाला analogy we can take over here. All right, and this is super important because we are also going to take up a lot of questions on this. Look at the last point, guys. Composition of two continuous functions is also continuous. Composition bole to, if I have a function which is continuous at a certain point or interval or domain, another one, then f of g or g of f, both of them will also be continuous. We will explore this concept as we move ahead with the questions. Make sure you are taking all this down and then we speed up. Alright, let's look at few more points which are super important. That polynomial functions are continuous everywhere. the trigonometric functions are continuous on their domain. So like sin x, cos x, they are continuous everywhere because their domain is real. Tan x, cot x, sec x and cosec x are continuous on their respective domains. Log x is continuous on its domain, which is open 0 to infinity. Mod x is continuous because we will be using all these concepts further. So super important to know them. Okay, chalo, now let's have some action. Okay, then now let's have some action. All right, this one came in CBSE 2011. Are you guys ready? Yeah? Okay, let's read this. It says discuss the continuity of the function at the point x equal to half, where the function has been split over this. तो ठीक है, LHL निकालते हैं. Whenever the function is split, LHL, RHL, value of the function, let's get them. Okay, so here when I start with LHL, I will say limit x tending to half from the minus side, means from the negative side of my real numbers. This doesn't mean minus half, please ensure. Okay, of fx is what? This is limit x tending to half. Let's select the appropriate function here. Less than half is this side, so the answer is half directly. Continuity होने के लिए obviously your limits have to be super strong. Do comment in the section below if you want me to make a separate video on limits of a function. Alright, same way we are going ahead with RHL, which will be limit x tending to half from the positive side of my number line. So this is going to be limit x tending to half from the positive side, means when x is greater than half. So this will be 3 by 2 minus x. 3 by 2 minus half. Oops, the answer is 1. So यहीं से fail हो जाती है condition of continuity. अगर आप निकालना भी चाहें what is f of half, that gives you 1. तो मतलब two of them are matching, but LHL and RHL itself, they are not the same. So this and this are unequal. We will say the function is discontinuous at half. Whereas we have to talk of the overall continuity. तो अभी बताया polynomial function, your constant function. So यानी whenever my x is between 0 and half, otherwise half being a constant function will be continuous. Same way x, if my x is this, if x is greater than half but then it is lower than 1, then also in this case the function stays the same. तो मतलब there is continuity everywhere except for the point half where it gets broken. Okay, so we will say the function is continuous everywhere except for the point x equal to 1 by 2. Please note this down and then we will rush to the second question. Alright guys, let's have a look at the second question. It says discuss the continuity of the function given by fx equal to mod x minus 1 plus mod x minus 2 at the points 1 and 2. Our very famous, our very own modulus function. Okay, so अब करना क्या है? We have to split the whole function. How would we do that? So how do I write mod of x minus 1 plus mod of x minus 2? First of all, where all are we going to split? Obviously, looking at this at 1 and looking at this at 2, क्योंकि आपका mod function always changes, will change itself at 1 and at 2. ठीक है? So let's do this. So मतलब interval, what is the interval that comes to me would be 1 is if I take x lower than 1, 1 I can take x to be more than 1 but less than 2, and another could be when I can take x to be greater than equal to 2. These three are super important for the reason because we have to check at the points 1 and 2. ठीक है? Let's see how each one of them behaves. Now you don't have to actually write this, but you can always say, you know, mod x minus 1 can get split like this. यहाँ बहुत गड़बड़ करते हैं बच्चे because they write x greater than equal to 0, whereas we are not supposed to do that. Everything depends on what's here. Okay guys, so this has to be greater than equal to 0. So that means x minus 1 greater than equal to 0 gives me x is greater than equal to 1. I hope you guys are understanding that. And same way when x minus 1 is less than 0, that gives me x is less than 1. That's how I've split them. Same way, आपका mod x minus 2 would give us x minus 2 when x is greater than equal to 2 and 2 minus x when x is less than 2. ठीक है? Let's do this. अब इनको combine करके we have to write here. So let's see how we do this. When x is less than 1, तो आपका mod x minus 1 is automatically 1 minus x. But मजे की बात ये है कि when your x is less than 1, तो quite by the common sense it is less than 2 also. तो दूसरा वाला भी हो जाएगा negative. So first is just redefining this function. This will give us what? The function as 3 minus x. Same way when it is between, अब this is very critical. It's more than 1, so that gives me x minus 1. But it is still less than 2, so this stays positive. मतलब यहाँ पे I am getting only 1. Okay, and greater than equal to 2. Obviously if the function is greater than equal to 2, it has to be more than 1 also. The first is also positive, second is also positive. That's giving me 2x minus 3. ठीक है जी, are we clear with all this? Let's make a note till this point before we go further. Alright, I'm just erasing this part so that we can now start solving. Alright, we've done this. Now what happens is, so if I take now, I'm checking at 1. So limit x tending to 1 minus of fx. So approaching 1 from the left side, I am getting 3 minus x. When I put the value, I'll get a 2. And limit x tending to 1 from my right side gives me limit x tending to 1. What will I have? The function I have is 1 here. Okay, the function which I have is 1 here. So this is automatically 1. And value of the function at 1 is also 1. Sorry, please note this is 3 minus 2x. So here it has to be 2x. Okay, so मतलब यहाँ पे we will not get 3 minus x, we'll get 3 minus 2x. So this will get 3 minus 2, which is 1. All three are equal. All three are equal. So what do we get? Absolutely right. We are going to get 1. So that means it is continuous at 1. It is continuous at 1. Same way, let's check at 2. So continuous at x equal to 2. What do we do? If I say limit x tending to 2 minus, this will be limit x tending to 2. Alright. 2 minus matlab left side of 2. So I am getting only 1. 1 is the answer. Limit x tending to 2 plus, which is giving us limit x tending to 2. And what do we have? More than 2. This is more than 2, guys. So it has to be coming from here. What was this when we solved? This is 2x minus 3. So let's put this here. 2x minus 3. So this will be 2 into 2, 4 minus 3, 1. And value of the function at 2 is also, my dear friend, 1. So all three are equal again. So the function is continuous at 1 also and at 2 also. So, I mean, you don't have to show everything separately. You can do this. You can write this quickly and then just get to your continuity checking. Alright? Please make a note. Chalo, let's move to question number 3. Came in 2012. The question says, if the function is given by this complicated looking equation, it's broken this way, then in that case, but this time you are given Yeah, this time we are given that the function is continuous at 1. So we have to find a and b. In questions may never ever begin with your question without giving the definition, because that actually has marks in the paper. So we are going to say, we will say since fx is continuous at x equal to 1. Sorry, I'm very lazy, I don't want to repeat writing. So since fx is continuous at x equal to 1, therefore limit x tending to 1 from the left side. ये मैं left right क्यों कर रही हूँ? Because my function is split. More than 1 and less than 1, the function is different, as you can see. Okay? Is equal to limit x tending to 1 plus is equal to value of the function at 1. Okay, chalo, this 1 and is mixed. Okay, all right, this is limit x tending to 1 from the left side. This is 5 ax minus 2b is equal to limit x tending to 1 plus matlab zyada, so 3ax plus b. Value of the function at 1 is 11. Let's solve this, right? So I will get, this implies this will be 5a minus 2b is equal to 11. And I have 3a plus b is equal to 11. Let's solve this quickly. Let's do that. Alright, so what do we get? We get 5a minus 2b is equal to 11. Here I can say this is 6a plus 2b is equal to 22. That means 11a is 33. So a is definitely 3. Are you guys getting a as 3? Yes or no? Come on, let's do this together. A is equal to 3. So in this case, okay, yeah, so now I can put this a as 3 anywhere. This will be 9a plus b is equal to 11. A hai kya mera? So now let's put the value of a over here, which will be 3 into 3. That's a 9 plus b is 11. That means b is equal to 2. Superb. That means we've got a is equal to 3, b is equal to 2. Now it's your turn to note this down. Alright, let's move to our question number 4. Let's do this one together. Please read the question. It says let fx be this Herculean looking equations. Determine the value of a so that fx is continuous at x equal to 0. मतलब आप बिल्कुल wait मत करो, शुरू हो जाओ find करना quickly. And before I solve, you guys should solve. Because you know, you will have to say since fx is continuous at x equal to 0. फिर से है question में twist. फिर से है question में split. So we will say this. Once again, each time we are writing this. I mean, don't get harrowed कि ये बार बार लिखना पड़ रहा है, क्योंकि सवाल आपके पेपर में एक या दो ही आएंगे in your midterms, and in finals it's just going to be one, right? Okay. So once again, limit x tending to 0 from the left side gives us 1 minus cos 4x upon x square is equal to limit x tending to 0 from the positive side will be root x upon 16 plus root x minus 4 is equal to value at 0. So you will actually get the answer by equating any two, lekin it is important to confirm your answer doing the other two also. Matlab, if I start by doing first and third, okay, so this one is limit x tending to 0, my very famous 2 sine square 2x by x square. अब इसको x square बनाने के लिए I'll have to multiply and divide with 4. This is equal to a. I'm equating the first and the third one, right? So what will this become? This part, guys, limit x tending to 0, sine x by x is 1 if you remember. So I don't have to, so that means this becomes 1, and that means this 4 goes up and your a is 8. So a is equal to 8 तो आ गया, but for your school exams you have to confirm it from the other side also. कैसे करेंगे ये next side? I can rationalize. So this will be limit x tending to 0. This will be root x into root of 16 plus root x plus 4 and नीचे क्या आ जाएगा आपका? I'm just directly writing 16 plus root x minus 16. Awesome. Why awesome? Because 16 and 16 are getting cancelled. This root x and root x are getting cancelled. Right? So what are we left with if I put the values? This would be root 16 plus 0. So 4 plus 4, how much is it? अभी तक तो 80 है. So that means you are getting answer 8 from both the sides. Please make a note. Alright, let's get started with question number 5. I hope you guys have already read the question. Let's start. Yep. What does it say? Prove that the greatest integer function. अब याद है greatest integer function, step function. Comment में लिखो if you want me to make a video on functions. Okay? So prove that the greatest integer function, which is this, is continuous at all points except for the integral points. अब जल्दी से बता देते हैं greatest integer function को याद करने का तरीका. Basically, बड़े टेक्निकल लैंग्वेज में जाएंगे तो इट सेज ग्रेटेस्ट इंटीजर लेस देन इक्वल टू एक्स. मतलब whatever real value I put here, it will always give me the answer on the left side, the first integer that I spot on its left. मतलब if I'm talking about 2.8, so as I move on the left side, the first integer जो मुझे मिलता है that is 2. So the answer for this is 2. So certainly we know the output is always integer. Okay? लेकिन if I have minus 2.8, okay, if I have minus 2.8 तो याद रखना लेफ्ट साइड में आता है -3, not -2. -2 is greater than -2.8, right? So this is -3. Right, this is something about your greatest integer function. Okay, so let's do this. Now I have not been given any specific value where I have to check. कोई बात नहीं, assume कर लेते हैं. So let me say let A belonging to Z. मतलब let A be any integer that I'm talking about. अब मुझे check करना है from the left hand side of A and from the right hand side of A and at A, am I getting the same answer? If not, मतलब यहाँ तो लिखा ही है it will not turn out to be the same. So let's check that. Okay, so here for LHL at A, that means limit x tending to a minus of greatest integer. अच्छा, now I'm going to use h. Why h? क्योंकि यहाँ कोई separate नहीं दिया मुझे, already split नहीं है मेरा function that I can choose a specific function and use it. तो what can I do? I can call my x as a minus h. क्योंकि x tending to a का मतलब क्या है? If this is a, I am moving from left side. तो आई एम अप्रोचिंग, यानी a से थोड़ी सी छोटी वैल्यूज वी आर कंसिडरिंग. सो a माइनस थोड़ा सा अमाउंट, राइट? सो दिस बिकम्स लिमिट h टेंडिंग टू 0. वाई 0? बिकॉज हमने बोला थोड़ा सा अमाउंट. एंड हियर इन प्लेस ऑफ x आई विल हैव a माइनस h. अब थोड़ा सा जस्ट यूज योर कॉमन सेंस. इफ द नंबर इज 3, ओके, सपोज माई a was 3 में से I subtracted just a tiny bit. Okay, so let's say it became 2.999. Okay, greatest integer value 2. तो मतलब if I started with 3, I came back to 2 for the given situation, क्योंकि 3 minus h will give me 2. ठीक है? तो same way अगर मेरे पास general a है, so I will roll back to an integer value which is less than this, which will be a minus 1. अगर ये समझ आ गया तो सब समझ आ गया. Okay, क्योंकि a से a little bit we are taking out, so it will move back, move on the left side. a से छोटा integer क्या होगा? a minus 1. Alright? Same way when I talk of RHL at A, what happens here? Limit x tending to a plus of this greatest integer function. I will now apply the same logic. Let your x be a plus h. Wow, such a beautiful combination of red and green. Okay, limit h tending to 0. We will have a plus h. अब a से थोड़ा सा ज़्यादा, we'll roll it back to a, guys. And value of the function at a. Okay, it's not mentioned to be f. So simply value of the function at a. Obviously integer का value तो will be the same. A problem है that left hand side and right hand limit, they do not match. So overall the function is discontinuous at a. अब a था एक random point. So that means if the function, greatest integer function, is discontinuous at a, it has to be discontinuous at every integral points that we have, and that's exactly what we had to show. Alright, look at this sixth question. Show that this function is continuous at x equal to 0. So you actually have to show this. So matlab, let's take this. It's quite simple. LHL hai, limit x tending to 0 from the left side. This is giving us sin 3x upon tan 2x. We already know this, what we can do. Yes or no? I can multiply and divide with 3x here on the top and multiply and divide with 2x here. Okay? We can do that. And what happens now? This is going to be 1, this is going to be 1, x cancel. Okay, the answer is simply 3 by 2. Right? Value of the function at 0 is already coming out to be 3 by 2. I mean, it's right there. And for my RHL, what will I do? Okay, this fx. So log of 1 plus 3x e raised to power 2x minus 1. Acha, this one is a combination of two properties that we have done in class 11th. One is limit x tending to 0 log of 1 plus x upon x is 1. ये चीज याद रखना कि this and this, they should be the same and must tend to 0, right? Another one, limit x tending to 0 e raised to power x minus 1 by x. So again, this and this, they have to be the same and should tend to 0. This will also give us the answer 1. Okay? Alright. So what happens now is, how do I make use of these two properties? What I can do for this question is, first of all, I can divide both of them with x, because guys, we need x, right? Okay, now what I can do is, I need 3 here. So multiply and divide with 3 here and multiply and divide with 2 here. This guy, limit x tending to 0 is 1. This guy, limit x tending to 0 will be 1. What am I left with? 3 by 2. So now LHL at 0 is equal to RHL at 0 is equal to value of the function at 0, all of them being 3 by 2. We are good to go. Alright, let's read the next one. Find the value of a for which this function defined by fx is continuous at x equal to 0. अब तक तो I think we are becoming pro at this, right? मतलब अगर ये lecture beginning से end तक कर लिया तो सब कर लिया, right? So here we have again limit x tending to 0 from the negative side. I think इस question में ज़्यादा कुछ नहीं है. It's only about how you actually tackle your limits. So if you are good at class 11 limits, तो ये तो बिल्कुल बच्चों का खेल है. Okay, so limit x tending to 0 a sin pi by 2 times x plus 1. Here I can directly substitute, because if my x is 0, this becomes a sin pi by 2. Sin pi by 2 होता है 1, so the answer is a. ठीक है? Next, we are already given actually it's continuous, so LHL and RHL will be equal, right? So RHL is, RHL को solve करना is slightly tricky, but what I can do is I can write this tan x as sin x by cos x minus sin x. upon x cube. Okay, this will be limit x tending to 0. ये आ जाएगा आपका, if I take sin x common, I'll be left with 1 by cos x minus 1. So I'm taking the LCM directly. ठीक है? Are we good with all this? Alright, now what we are doing is limit x tending to 0. This is sin x by cos x, which I can write as tan x. Too hungry, I've eaten my 0. Alright, tan x by x. And 1 minus cos x I can write as 2 sin square x by 2. देखो x cube को x here, x square here, and I am sorted, right? So now what I can do is, we know limit x tending to 0, tan x by x is 1. We also know I want x by 2, तो I can multiply divide with 4. तो ये चीज भी हो जाएगी आपकी 1, ठीक है? So what are we going to get here? Yes, we will be left with half as the answer. And now we are given, and even the value of the function at 0, this is also actually my a only. So since the function is continuous, हम नहीं भूलेंगे writing the full definition, and then we will happily say a is equal to half. So the answer is a is equal to half. Please note this down. Okay, are we guys ready for the 8th question? Come on, let's say yes. Okay, if fx is this huge looking question, again continuous at 2, find k. The idea behind today's session is कि आप लोगों को इतना strong कर दे in continuity that you can tackle any problem here. Okay, so here what happens is, for continuity at 2, it's already given to be continuous. So if I start with my, I don't have to now start with my left side or right side, क्योंकि x greater than 2 है या less than 2 है, my function is the same. So I will start by saying that this fx is equal to value of the function at 2, which is a k. So here I'll get limit x tending to 2. The whole point lies in how do I simplify this, because obviously 0 by 0 form, if I put x as 0, यहाँ पे I can write this as 2 raised to pi x into 2 square minus 16 upon 4 raised to pi x minus 16. Further, limit x tending to 2. This 2 square can become 4, right? Now, if I take 4 common, I am left with 2 raised to pi x minus 4. Why did I do this? Because इसको भी हम लिख सकते हैं a square minus b square. So what will this give us? 2 raised to pi x minus 4 into 2 raised to pi x plus 4. Alright, let's do this. The culprit, the problematic expression which was making it 0 by 0 is now gone. So x equal to 0, x equal to 2, we'll get 4 upon 2 square plus 4. This is equal to k. So how much is it? Half. Half is the answer, right? So similar, guys, so similar. Question number 9. fx is continuous at x equal to pi by 2. What happens? What is the value for a and b? चलो जल्दी से करके बताओ. Let's do this. So this time again, I can start with this LHL. For my LHL, limit x tending to pi by 2, I'm directly writing this. Ab a cube minus b cube. What is a cube minus b cube? These are all very important questions. A minus b into a square plus ab plus b square. Right, guys? So this one becomes a minus b, that means 1 minus sine x into 1 plus sine square x plus sine x. ठीक है? This cos square x can be written as 1 minus sine square x, which can be further split as 1 minus sine x into 1 plus sine x. Why did I do this? So that I can cancel out the culprit. What's my culprit? 1 minus sine x. Now if I put the value, what do I get? Pi by 2 if I put here. Sine pi by 2 is 1. This is 1. So 3 upon 3 into 2. That means half. And guys, what's the value of the function at x equal to pi by 2? It's a. So that means I've already got my a as half. अब solve करना है from the right side, right? So what do we do? RHL. Let's do RHL. Yep. So we have limit x tending to pi by 2 b into 1 minus sine x pi minus 2x whole square. How do I tackle this? So there is a beautiful way. What we can do is I can take this as y. Remember we used to do all this in class 11. Pi minus 2x as y. So यहाँ से x क्या आएगा? Your x will be pi by 2 minus y by 2. Wow, how rhyming. Yeah, because if I take 2x on the other side, this will be pi by 2 minus y by 2. Let's put everything. So that means limit y tending to 0 b into 1 minus sine x will be 1 minus sine of x की जगह pi by 2 minus y by 2 upon y square. Are we guys clear till here? Keep noting. I want to use this space, guys. Please note this. Alright, now what do I do? Limit y tending to 0, b is as it is. 1 minus sine pi by 2 क्या देता है आपको? 1 minus cos y by 2. And 1 minus cos y by 2 हो जाएगा 2 sine square y by 4. What property am I using? I'm using 1 minus cos 2 theta is equal to 2 sine square theta. Here in place of 2 theta I have y by 2. So इसका भी half will give me y by 4. Isn't it? Alright, this is what we have upon y square. Okay? अब ये मुझे यूज करना है. So what am I going to do? Multiply, divide by 16. Why 16? देखो सबसे पहले why did I actually have to substitute? Reason being जब भी है sin, cos, tan, you've only done the formula which says limit y tending to 0 sin y by y is 1 or tan y by y is 1 like that. Okay? So why did I use 16? Because इसको जाना है whole square के अंदर. So I need like this, right? So in order to create this 4, I have to multiply and divide with 4 square, and that's how it's 16. All right. So what do I get? This portion again becomes 1. I'm left with this gets cancelled. B by 8 is equal to value at pi by 2, which is a. So I will get b by 8 is equal to a, which is half. तो मतलब b आ जाता है आपका 4. So b is 4. Wasn't that interesting? Come on, make a note. Okay, now let's come to composition. This one we'll be able to do super quick. How? Look at this, guys. Alright, prove that this is continuous everywhere. Okay, this is continuous everywhere. Now, how do I deal with this? I see two functions hidden behind this. If I call fx as 1 minus x plus mod x, and if I take another function gx as, let's say, mod x, because here this entire expression is again inside the mod. Okay, so it's a mixture of two functions. we already know, guys, that mod x is continuous everywhere. We know 1 minus x being a polynomial function is continuous everywhere, right? We know sum of two continuous functions is continuous everywhere. So, sum of two continuous functions is continuous everywhere. इसका मतलब ये that my fx is continuous everywhere. What's my gx? Gx is also continuous everywhere. अब इसका कैसे mixture बनाए? Shall we do f of g or g of f? Quickly guys, tell me. See, if you do f of gx, that will not help you. Okay, you can try doing that. So rather, if you try doing g of fx, matlab inside g I'm putting this whole function. Obviously gx is mod x, so everything automatically comes inside the mod. So what are we going to say? I'm going to say, since fx is continuous everywhere, gx is continuous everywhere, so g of fx will also be continuous everywhere. Composition of two functions, isn't it? Alright, fx equal to cos of x square, you have to show is continuous. Again, mixture of two. Let's say fx is cos x. Obviously it's continuous everywhere because the domain is R, so continuous everywhere. We did that in the beginning. Same way, if gx is x square, again is continuous everywhere. अब मैं क्या करूँ, f of g or g of f? Yes, you're right. f of gx. Why? Because f of gx is x square. So I'll get cos of x square is continuous everywhere. Simple सा सवाल. Okay, we are on the let's solve it section. That means here you have to give your answers. थोड़ा सा hint दे देते हैं. Given the function fx is 1 upon x plus 2, find the points of discontinuity of the function f of fx. ठीक है? So first of all, how do I find f of fx? f of fx is equal to f of 1 upon x plus 2, right? That means it has to be 1 upon x plus 2 plus 2, which gives us x plus 2, and here it will be 1 plus 2x plus 4, so 2x plus 5. ठीक है? So now tell me, where all? Is it 1? Is it 2? How many points? Is the function going to be discontinuous? Just a little hint to you guys. For the function to be continuous, पहले उसे defined होना चाहिए. So here one hint is one of the points where it will be discontinuous is x equal to minus 2. Because since it's in the denominator, the function is not defined at minus 2. You have enough hint. Comment in the section below if this is the remaining function, where else is it discontinuous. Alright, answer quickly because you know I will be announcing the correct answer in the next video along with your names. Please solve it. Let's solve it. Alright, thank you so much guys for attending this session. Also check out, you can download the Vedantu Learning app for your awesome live classes, study material, access to exclusive masterclasses, practice tests, don't miss that out. Alright, get your free session PDFs now, so you can just look at that. Also, if you enjoyed this video, make sure to like it, share it with everybody, subscribe to Vedantu Math channel. Alright, keep sharing your feedback as to what more do you want on this channel. This is Neha signing off. Bye-bye.